Okay, here today, what you guys missed is just going through some different things. There's only really one new thing to add to today, but we want to kind of put a bow on this, all this different factoring and everything else like that. So as I look at this particular problem, I just want to tell you how and what I think of as I look at a problem like this and what the process is. So I'm going to go through to be able to solve this. So the first thing I do is I notice that there are four terms. As soon as I see four terms, I think factor by grouping, no matter what. Every single time I see four terms. Um, you could see, you could think factor by grouping no matter what you get, as long as you have, no matter what. But I prefer to factor it normally, what I call normally, when I see a trinomial. But when I see four terms, I think factor by grouping. So I'm looking at the first two. What can I take out of those two? I can divide both of these two by x2. So if I divide x to the third divided by x to the second, those cross off. There's just one x left. And x to the second divided by x to the second is 1. Now, once I make this one, I'm trying to match this with the other one. So as I see these two, I'm going to take out a negative 9. So I'm going to divide everything by negative 9, which what that does is that gives me my x plus 1. Now, I'm in great shape. I just got this done, so I'm going to go with the pairs and the spares. Now, every time I see squared, and I want to see squared because squares are ones I can factor pretty easily. So when I see squared, I think, can I factor that again? And at this point, there's two different ways to do this. Here's how I would suggest that you guys do it. And this one's going to end up to be negative 1. That one's a nice, easy one to do. Here, let's follow that same format. So I get x squared is equal to 9. I take the square root of both sides. Remember, when I put in the square root, I want plus and minus that particular value to get this one. So now, the other option that I would go through, and that option, when I do these, this is what I see, and this is how I was kind of raised to do this. First of all, the first one is still, that's going to end up to be negative 1. There's nothing I can do that. But when I see x squared, I think, can I factor that? And I can. I'm looking for two numbers that multiply to make negative 9 and add to make 0. Well, that's 3 and negative 3. So that means I'm going to get x minus 3, x plus 3, x minus 3 equals 0, x equals 3, and x equals actually negative 3, and x equals 3. So there are my two answers, and here's my third answer. Same thing as this way. The good thing about doing it in this manner right here, is in this manner in black, that means it's just more consistent. It works for a bigger variety of problems. So that's why I would probably do it that way. Let's see, another problem is right here. Again, I see 1, 2, 3, 4 terms. I'm going to look every single time, can I make this smaller? Because if I can make it smaller, it makes it easier. And unfortunately, there isn't an x in everything, and I can't divide everything by 2. So let's see. Let's look at these first two. So let's take out an x squared. And in the back, let's take out a 16. And then I end up with the pairs and the spares. Okay, now this is a great example of why I would choose to use the method of the previous one in black as opposed to in red. This one is there, so that's easy to do. But this one causes me some pain. So when I subtract that 16, I get negative 16. Then when I take the square root, well, I'm going to get x is equal to plus or minus 4i. And we haven't spent a whole lot of time with I, but it's just one of those that doesn't work out very well. So that's why I would suggest that you just follow this format, because it can't factor. Because this is an imaginary answer, that's what I get, and that's where I stay. Okay, now next set of problems. So here's this one. Here's the thing that I'd like for you to notice here. This 12 is not, it should be a 0. So let's move the 12 over. So I get x to the fourth minus 7x squared plus 12 equals 0. Now, in this particular case, there's only 3 terms, so that opens up my factoring techniques. Now, I'm going to show you how to factor this one by grouping, just so that I show you that, hey, factoring by grouping works all the time. There's nothing wrong with doing it this way all the time. It may not be the fastest, but it works every single time, so that's a big advantage. So if I do this by factoring by grouping, I'm going to take the coefficient of the biggest degree and multiply that by the constant value. So it multiplies to make 12, adds to make -7. That's this value. Okay, well, those two numbers are -4 and -3. So this one gets written down. I pick one of the factors, and I usually write them down right in the same order. Now, I'm used to just putting an x, but see how this is x squared? This must have the same degree as the middle term. So that's how I get this. And then this one comes down plus 12. Now I factor by grouping. What can I take out of here? I can take out an x to the third. I'm left with x minus 4. These two I can take out a -3. I get x minus 4. Pairs and spares. There's the pairs. There's the spares. And that's an answer that I'm looking for today. That's all I need to have out of that. This one just doesn't work out very well. Okay, now let's try another one. Okay, same problem here. I got that 12 over there. So let's take out 3x to the fourth plus 15x squared plus 12 equals 0. Now I always look, can I make these problems smaller? I don't like a number out in front of my x squared term because it makes it harder. So let's divide everything by 3. Okay, now let's factor this. Now I'll show you this way called what I call the normal way of factoring, because this is just factor by grouping is kind of new to me, but this is how I would do this one. The 3 comes along no matter what, and I'll split the x to the fourth up into 2 different ones. Now what multiplies to make 4 and adds to make 5? Well, 4 and 1. Now this particular problem should have 4 answers. Now in this case, when I subtract the 4 from both sides to take the square root, I get x is plus or minus 2i. This one, same type of problem. So now the 3 doesn't get set equal to 0 because there isn't an x there. But 1, 2, 3, 4, those are my answers. And now this last problem here, this looks like a doozy. Well, I notice I can divide everything by 2. Now, I've been asked on occasions, do I have to do this? You don't have to do this. The advantage to doing it this way is it makes the numbers smaller. And that sometimes is a lot easier and easier to deal with, easier to work with. 4 terms. That means factor by grouping to me. And I'll take out an x squared. This one I'll take out a 4. Pairs and spares. And that right there is a good enough answer for us. Again, if I were to finish this off, I get 3 and x equals plus or minus 2i, which is my 1, 2, 3 answers, which that's what I was looking for. But the only real answer I get is that one. All right, now special cases to find all solutions. So let's just keep rolling. Here is a big table about all the different ways to do these things. And I got to tell you, I most definitely do this. I take out the greatest common factor because I want the numbers smaller. The rest of these, they really don't make any difference to me at all. I don't necessarily do any of these things as I look at this. Trinomials, So if I had something like, that's an example of that. Perfect square trinomials. Okay, so that means I'm going to do something like, and then the difference of two squares. Okay, now, like on this one, I need to multiply. It multiplies to make 16, but adds to make 10. So that'd be 8 and 2. This one, it multiplies to make 16 and adds to make negative 8. X minus 4, x minus 4. This one, it multiplies to make negative 16, adds to make 0. X minus 4, x plus 4. So as you can see, I don't do these any differently. They talk about these three are different ways of doing this. Every one of them requires something different. I don't do it that way because I don't want to get confused. Okay. Now, actually, I could do all these by factor by grouping, and I've shown you about how to do a lot of those. But remember, anytime I see four terms, I know for sure I'm going factor by grouping. The last one here is the difference of two cubes. Well, this is new to us, and I want to discuss this one as we get ready to end today. So, if I had the difference of two cubes, the first thing I want to do is I need to recognize these. So, the cube needs to multiply by itself that many times. So, here are my perfect cubes that I know right off the top of my head. Those for sure. Now 6, now this one gets a little iffy. All right, but those are ones I know right away. So let's say I had x to the third plus 125. Here's how I would do this. First of all, I see that this is a 1, so it's on my list, and 125 is on my list. So I'm going to take this as x to the third plus 5 to the third. The reason I do this is I want to match up with my examples here. A to the third plus b to the third is this. So I want to know what a is and what b is. So according to this pattern, this will factor as a plus b times a squared. Then I multiply a times b, and I take the opposite sign. So I get 5 times x is 5x minus, so then I flip the sign. And I square the last one. And that's how I factor those. Now, these are always, these are ones that I got to practice. I got to remember from day to day, week to week, and everything else like this. So I would suggest you practice quite a few of these to help you out with this. Now this one, x to the third minus 8. So I have x to the third minus 2 to the third. Okay, so yep, these fit the criteria. It's in the right format. Here we go with this. So this will be x minus 2. So it's a minus b. And then x squared, a times b, the opposite sign, and b squared. And many times when I factor these, what I get left can't be factored either. So that usually means that this is where this particular problem ends. Now let's try another one. I'll change the colors. So now I have 27x to the third plus 64 equals 0. 27, if I go to my list, 27 and 64 are both there. So this is 3x to the third plus 4 to the third. 3x plus 4. Now I multiply it, square this. 3x times 3x is 9x squared. Multiplying 3 times 4 is 12x, but it's the opposite sign, and square the last one. And there we go. Okay, so now this is a new one for us as far as factoring, so you have to be careful with this. And I would suggest that you follow that pattern as best you can. I really like to rewrite the problems so I can see what they are, what their cubes are, and things like that. It makes it easier for me not to make that mistake, but it doesn't guarantee that I don't. Last slide here. I think this is about the last slide. So here we are again. You could do, I would do step one every time. You could do step two every time. And then you'd have to do step four. Step three can be covered in step two. If you want to use factor by grouping, you can do that all the time, every time. It gets a little tedious though. Okay, so find all the solutions to this problem. So that means everything. First thing I do is I look at this, three terms, x to the fourth. I don't like x to the fourth. So maybe I can take an x out of all these things, which luckily I can. So x squared minus 8x plus 16. All right, so the x squared comes along for a ride. I'm going to set these up as if they're normal because it goes x squared to x. So I'm going to put x here, x here. What times what multiplies to make 16 and adds to make negative 8? Well, to me, that looks like that's negative 4 and negative 4. Now, if I'm finding a solution, I want to set these equal to 0 and finish this off. So x is equal to 0 with a multiplicity of 2 because it's squared. This is x equals 4. This is x equals 4. So I could put a multiplicity of 2. Now, I'd expected 4 answers, and I have 1, 2, 3, 4. So there we go. This one, okay? I'm always looking to see, can I take something out? And at first glance, I don't see anything, but I really don't like a negative sign in front of my x squared term. It just makes it ugly. So let's factor out a negative 1. Now that's going to flip all the signs. Now I want to look at this one. It multiplies to make negative 9, adds to make negative 8. That sounds like my combination is negative 9 and 1. Okay. Whoop, this should be x squared. All right, so now, hey, I can finish this. I'm expecting 4 answers. I don't set this equal to 0 because there's a 1 and not an x. So this one, and let's just finish this off. And this one, x squared is equal to negative 1. X is equal to plus or minus square root. Actually, x equals plus or minus I. There we go. And that's it for today. Hopefully this will help you guys out. Hopefully I'll get a chance to see you guys tomorrow.